Hello everyone, welcome to this video on group 15 elements. And the reason I am dealing with individual groups in P block elements chapter is that when we take the modular approach, when we divide the chapter into sub modules and then even more sub modules, it's easy to learn, and it's actually your brain can take more data, and you can pretty much like do the complete chapter in this approach. And I use this approach, and I can tell you that it's better than just doing the whole chapter in one go. So let's start with the first group, which is the group 15. And as you can see that this is a periodic table, and nitrogen is heading this group, and you can observe that this is the third group in the periodic table in the P block. And by the way, if you don't know what the P block is, well, it starts from this boron family, and then we have the carbon family, and then when we have the nitrogen family, which is what we are dealing with today. The electronic configuration of this is NP3 and NS2 also, which sits before this, and we are going to talk about this later in this video. But then we have the oxygen family, which has oxygen, sulfur, and selenium, tellurium, like that. And then we have all the electronegative elements: fluorine, chlorine, bromine, and then we have the noble gases. So in total we have 1 2 3 4 5 6 groups in the P block, but today we are only focusing on this. So it has 1 2 3 4 5 elements, and as I already told you, nitrogen sits at the top, then we have phosphorus, then we have arsenic, then we have antimony, and then we have finally bismuth. You can just ignore this last element because this is a synthetic metal and we are not concerned about this element. Okay, and one thing to note here is that helium, which also sits in the P block, actually has a electronic configuration of 1s2. So this is definitely an exception, but you should note that it's a member of P block family. Okay, so let's move to the second slide. So in this I have taken the images from Wikipedia of all the elements occurring in their natural state. So we have I have not added the image of nitrogen because hopefully that's obvious that it's a diatomic gas, and when we think about nitrogen, we generally conceptualize it as a naturally occurring gas, which is the case. But after nitrogen we have phosphorus, which is a non-metal, and then we have arsenic and antimony. These two guys are metalloids, and then finally we have bismuth element, which is a metal. Okay, let's move to the third slide. So I mentioned three words right now: metals, metalloids, and non-metals. What do I mean by that? Well, hopefully you are already familiar with metal and non-metal, but a metalloid is something that sits between the two. It has partial properties of metals and then partial properties of non-metals, so hopefully that makes sense. Now, how can you memorize which of the elements in the group 15 is a non-metal or a metalloid or a metal? Well, it's actually pretty simple. This is how I learned it. First of all, you have to remember the order of occurrence of group 15 elements. So it's going to be something like nitrogen, phosphorus, arsenic, antimony, and bismuth. And then just take the two elements in a pair. So in the first pair we have nitrogen and phosphorus. Nitrogen, we know it's a diatomic gas, so it's a non-metal. Same is the case with phosphorus. So the first two elements, or the first pair, is a non-metallic pair. And then we have a middle pair in which we have arsenic and antimony. These two elements are metalloids. And then finally we have bismuth, which is the metal, and hopefully that makes sense because all the elements that are typically at the bottommost layer of the periodic table are generally metals only. Okay, so this is a way to memorize which of the elements is metal, non-metal, or metalloid. Let's move on. Let's move to the fourth slide. Okay, so this is the table that I have taken from the NCERT textbook, and I want to focus on the physical properties of group 15 elements. And you can notice that all the elements are mentioned here as column headers. So we have nitrogen, we have phosphorus, arsenic, antimony, and bismuth. And by the way, if you cannot memorize all these elements in the specific order, well, you can check out one of many mnemonics on the internet in order to memorize this. But you have to memorize these elements in their specific order. And the way I did it was pretty simple. Actually, I just wrote it down like 3-4 times, and then I studied their physical and chemical properties. And when I did that, I remembered and I memorized these elements in a natural way. So hopefully you can do in a similar way, you can learn in a similar way. But let's focus on the physical properties for now. And I want to talk about all these properties. So let's talk about atomic number. This is pretty simple. Atomic number actually represents the number of protons. So when we move down the group, when we move from nitrogen to bismuth, what you will expect is that the size is going to increase and the number of protons is going to increase. So what that means is that atomic number and atomic mass is going to increase. Now, electronic configuration, I want to talk specifically about this. So let's move to the next slide. Let's move to the fifth slide. Okay, so I already mentioned that for a p block element, for a general p block element, the electronic configuration is ns2 and then np126. What that basically means is that the outermost shell has two orbitals, s and p. S orbital is completely filled with two electrons, so it will exactly have two electrons always. But the p orbitals is not completely filled, or it can be completely filled, so it can have electrons ranging from 1 to 6. And specifically, if we have exactly 3 electrons in the p orbital, then we have the following configuration, ns2 np3, and this is the configuration of group 15 elements. And one thing to note again is that helium has an electronic configuration of 1s2, but it's still a p block element. Okay, so I want to talk about the second property, which is the atomic and ionic radii. So as you can probably guess, when we move down the group from nitrogen to bismuth, first of all, let me jump back to the periodic table. As we move down the group from nitrogen to bismuth, the size of the element increases, and what that means is the radii is going to increase. And one thing to note here is that when we move from nitrogen to phosphorus, there's a considerable amount of increase in the radii. But when we move from arsenic to bismuth, I mean arsenic to antimony or antimony to bismuth, there's a very less amount of increase in the radii. And this is because of the involvement of d orbital. As we know that d orbital is actually closer to the nucleus, so the effect is that when we have a completely filled d orbital, what that means is that the size is going to increase when we move down, but there's going to be less pronounced increase, so the difference is not going to be that much. So can you write the electronic configuration of all these elements? Well, let's try to do that. For nitrogen, we have 1s2. Oops, let me switch to white. We have 1s2 for nitrogen, right? 1s2, and then we have 1p3, and then we have, oops, this is not right. We have 1s2, and then we have 2s2, and then we have 2p3. We can also represent this like electronic configuration of helium. We indicate this by putting helium in brackets, and we know that electronic configuration of helium is 1s2, and then we can simply write 2s2 and 2p3. So this is the electronic configuration of nitrogen. you can in a similar way calculate the electronic configurations of all the elements, and it's actually given in this table that we saw earlier. So you can see all the electronic configurations. Now I want to talk about the fourth property, I guess the third property, which is the ionization enthalpy. So I want to talk about ionization enthalpy. So ionization enthalpy decreases down the group because of the gradual increase in atomic size, and this makes sense because when we move down the group, the metallic character increases. Okay, so not much here in this property, and let's move to the final property, which is the let me change to black, which is electronegativity. So by electronegativity we mean generally the tendency of an element to pull electrons. That's how you can imagine electronegativity. So again, let's move back to the periodic table and let's consider this group. Well, as you move from bottom to the top, the electronegativity definitely increases, and this is because if you consider the reverse case, when we move from top to bottom, new orbitals start to add up, they start adding up, and what that basically does is that it increases the size distance from the nucleus to the outermost shell, and this decreases the electronegativity property. So not much here in the electronegativity property, and we are only left with one final thing, so let me cover that. So first of all, let me do this. Okay, so physical properties of group 15 elements. So let me write it down here that first of all the elements in group 15 are polyatomic. Now what do I mean by polyatomic? Well, what that basically means is that all the elements can form molecules in which there are more than two atoms. So nitrogen can form a molecule in which it has like there are more than two atoms involved in that molecule, and similarly for the case for phosphorus, arsenic, antimony, and bismuth. So all the elements are polyatomic. So let me label this as the first property, and then the second property. In the second property we have, well, it's just the same as what we saw in, I think, in the third slide. This is the second property. Nitrogen and phosphorus are non-metals. The first pair is a non-metallic pair, and then the middle pair, which is the arsenic and antimony, it's actually a metalloid pair, and then finally the last element which is left is a metal. So this is the second property. All right, so this is the second property. Metals, non-metals, and metalloids. So what's the third property? Let's look at the third property now. The third property says that when we move from the top to the bottom, the boiling point increases, and this is because when we move from top to bottom, we have the more metallic nature, and when we have more metallic nature, the boiling point increases. This is because of metallic bonding. Okay, so let's write it down. Boiling point increases as we move down the group. Hopefully that makes sense. The metallic bonding increases down the group, and therefore the boiling point also increases. The final property is that all the elements show allotrophy. So all the elements, let me first write it down, then I'll explain you. All the elements show allotropy. So what do I mean by allotropy? Well, allotropy is just a property of an element in which by same molecular formula there can be different physical states of that element. So in the future videos I'm going to talk about like the phosphorus element, and then we are going to see the allotropic nature of phosphorus. And not only phosphorus, actually all the elements in this group, which is the 15th group, they show this property of allotropy, and which this is basically the same as saying that all the elements occur in multiple physical states, and that's about it. But the only thing to note here is that nitrogen, which definitely is the first member of this group, does not show this property. So nitrogen does not satisfy this property, and this is because of like peculiar nature and anomalous nature of nitrogen. And we are also going to study this next in the chemical properties section. So hopefully you found this video helpful, and I'm going to make the next presentation on the chemical properties of group 15 elements.